Here's another vectors question. It says relative to an origin. Here are points A and B. That's the position vector of A. That's the position vector of B. Find in exact form the cosine, not the angle AOB, the cosine of the angle. Find the area of the triangle OAB. And find the shortest distance from A to the line OB. Right, time for a picture. Actually, I'm going to draw the picture up here because there's plenty of space. Okay, let's draw our origin. There's our origin. Always draw this. And that's the position vector 0, 0, 0. Now, A is some point over here. And that's got position vector 1, 5, negative 1. And B can draw it someplace over here, which is 6, 3, negative 6. And it wants us to find the cosine of the angle AOB. So that's A to O to B. They want to find the cosine of this angle. If that's the angle, they want the cosine of that angle. Okay, well, obviously, we can say that the direction of this line, OA, is just the position vector 1, 5, negative 1. It's that, take away 0, that, take away 0, that, take away 0. And the position vector of this is, by a similar argument, 6, 3, negative 6. So we can simply write down for part A, nice and simply, that cosine of the angle must be equal to A dot B. I'm going to call that A, and I'm going to call that B. It's going to be A dot B over the modulus of A multiplied by the modulus of B. Now, A dot B, well, that's going to be 1, 5, negative 1, dotted with 6, 3, negative 6. Let's show all our work in for the examiner. So this is 1 multiplied by 6 plus 5 multiplied by 3 plus negative 1 multiplied by negative 6, which is 6, plus another 6, which is 12, plus 15, which is clearly 27. And the modulus of A is the square root of 1 squared plus 5 squared plus negative 1 squared, which is the square root of 27. And the square root of, and the modulus of B is going to be the square root of 6 squared plus 3 squared plus negative 6 squared, which is going to be the square root of 81, which is 9. So therefore, cos of this angle that we're looking for, cos of this angle is going to be 27 over root 27 multiplied by 9. Now we can divide top and bottom by 9, which would be equal to 3 over root 27, and rationalising it, multiplying top and bottom by root 27, you would get 3 root 27 over 27, which you can divide top and bottom by 3, which finally we get a 9th root 27. You get a 9th root 27, but actually I should I should simplify root 27 as root 3 multiplied by root 9, which is 3, so 3 root 3. So this is 3 root 3 over 9, which at last is a 3rd root 3. Now in the question it did ask to do it in simplified form, so it was very important. That's why there were 4 marks for something quite easy. Okay, so cos of this angle is a 3rd root 3. So I know I'm going to write in my picture here, cos of theta, not the angle, but cos of the angle is a 3rd root 3. Okay, and I can rub this stuff out now. Okay. Right, let's do the next bit, part the area of the triangle. Now the area of this triangle, the area of a non-right angled triangle, is always a half AB sine C. That means a half the length of the two sides multiplied by sine of the angle between them. Okay, so the length of this side, I had worked it out previously, is the modulus of A, and the modulus of A was the square, sorry, keep that half there. The modulus of this was the square root of 27. And the modulus of B, this one, was 9. Now, if I know cos of the angle is root 3 over 3, then I know sine, because I know that sine squared theta plus cos squared theta is equal to 1, I know that sine squared theta plus this squared, which turns out to be a third, must be 1. And I can take off a third of both sides, so sine squared theta must be 2/3, and sine theta is the square root of this, is the square root of 2/3. Now I know sine theta is positive. This is going to be, I can assume it's positive in the case because it's an acute angle. I can assume it's acute. Okay, so sine of C, or sine C in this case, is going to be the square root of 2 over 3. Okay, now the square root of 27, I'd simplified that previously as 3 root 3, multiplied by this 9, multiplied by root 2 over root 3. Now the root 3's cancel, and I get myself 3 half times 3 times 9, which is 27 over 2 root 2. And the answer therefore is 27 over 2 root 2. And that's my area. I was asked in exact form, that's why I had to use this sign here. I couldn't just tap it in the calculator. Okay? And we have worked out the area of the triangle OAB. And I'll just write that down here, 27 over 2 root 2. Okay, so rubbing this out. Now I'm asked for the shortest distance from A to the line OB. This is the line OB here. Now the shortest distance, I'm going to just draw that with a dotted line, must be the distance that meets that at right angles. So I want the length of this particular line here. Okay, now I know the cosine of that angle. Imagine here I've got myself a right angle triangle, which I'm going to draw this way up. Okay, I'm replicating this here. There's my theta, there. That's my right angle there. I want the length of this A to this point here I call X. I want that, which with reference to my angle is the opposite. What do I have? I have the length of OA. The length of OA from previous working is the square root of 27, and I know cos of the angle. Now I want to find this side here, so I know if I know in this case that I will use the sine formula. So sine theta is going to be the opposite over the hypotenuse. So sine theta is going to be the opposite, which I'm looking for, over root 27. But bear in mind, from the previous work, I worked out sine theta. Sine theta was actually root 2 over root 3. So this is root 2 over root 3. That's what I got on my previous working, is equal to the opposite over root 27. So the opposite must be root 2, root 27, which is 3 root 3, all over root 3. The root 3's cancel, and I get myself 3 root 2. So 3 root 2, which is the opposite side, which is the side up the distance I'm looking for, and I'm done.